Hello, today I would like to show you how I assemble my 3D printed design for FPV goggles for using OpenIPC with a phone. The most important part you will need is this Wi-Fi module. It is designed to be a removable part of the goggles in case it needs to be changed for upgrading. The heart of this module is a PCB like this, which I designed, and you can find a link to the design in the description. Um, it uses a single Wi-Fi module with a voltage regulator to enable it to be run on 5 volts since this adapter needs 3.3 volts. This board was actually provided to me for free by JLC PCB. I'll tell you more about them later. So in this enclosure, this board can be mounted together with SMA connectors and a small 30mm fan. Apart from that, you will need the other 3D printed parts, some M2 screws, and some of those rubber bangs which are used for vibration reduction on mounting flight controllers. And you'll also need two lenses. I am using Fresnel lenses of 42mm diameter, but I also made 3D printed mounts for 50mm diameter lenses. So let's start the assembly. To start off, I'm going to attach the lenses to the mounts. For me, they just fit together nicely, but if it's too loose, you can always add some super glue. Now I'm going to mount the lenses on these parts. As you can see, I have already attached double-sided tape for later, but you can attach it later. There are some slots for inserting M2 nuts here. Now, the way this mechanism works is you can slide the lens laterally, like so, to adjust for the interpupillary distance. And because these rubber bands can be squished, this also allows for changing the distance between the lens and the screen for adjusting focus, like so. I know that this is probably not the easiest to use mechanism, since you will need to remove the foam to access the screws, but once you set it up, it should be fine. So now I'll do the same for the other side. Here I'm actually adding two rubber bands because I know that with my eyes, they prefer to have this lens a bit further away from the eye. But of course, people with different eyesight will be able to adjust the distance, and also you can use lenses with a different focal length. I believe these are 40mm focal length, but I'll check later. And as you can see, with two rubber bands, I have a greater range of distance adjustment. So now, just to tell you more about this part, I used a USB cable from an old mouse, but I had to replace the connector from a USB Type A connector to USB Type C, and for that I used one of those adapters. However, when you buy one, make sure to get one which is compatible with USB OTG, which means that essentially once you plug it into your phone, it will tell your phone to give 5-volt power to it. Because for this one, to get it to work, I needed to add a resistor here, but I believe you can get some which already have all the resistors. So it's just so that you can power this module from your phone without any external power supply. So now I'm going to mount this module on here like so. Just make sure there is no cable in the way. This actually has hexagonal holes here in case you want to change the design on top to have screws coming from this side. But here I have the screws coming from the bottom, so I am not using the hexagons. Like so. Later we will attach the antennas here. And now you can see that there are slots, 4 slots around here for inserting M2 screws. So the screws coming to attach these parts have something to hold on to. I already have 2 of the screws inserted, so I'm just going to insert the remaining 2. And let's attach the parts. Let's do the same for the other side. Like so. Probably now you will want to put your phone here and see if the distances are right. But I'm just going to put this thing here. You'll need to apply some double-sided tape or some glue, but I've already done it, so this piece of foam just fits in. You can get those from AliExpress as replacements for some popular VR goggles. Yeah, fits very nicely. So now let's assemble this part. This part was actually designed for a specific phone, for a Samsung Galaxy A54 in a hard case. So if your phone has different dimensions, you might need to change the dimensions and add some tabs here for centering your phone. But hopefully it shouldn't be too much of an issue, since you can design different parts like this to be compatible with this main body. These holes here are for mounting triple feed patch antennas, like so. I still haven't tried using them, but this is just for a future upgrade. If I want to have two Wi-Fi modules here and 4 antennas, then they can also be used, or the patch antennas can also be used as a replacement of the antennas here, which I'm currently using. So for this part, you just need to put the nuts in. And these tabs, they are designed to slide into here, so you might want to sand them, as I did, to have a smoother motion. And they have this cutout here, so that when it's off center like this, it is held in place, but when you slide it here, it will go in under the action of rubber bands. So you'll just want to see which direction, because there are two versions. One is a mirrored version of the other. You can see I made the holes here a bit too big, and sometimes the nut will rotate inside. So in that case, you can hold the nut with something else to prevent it from moving as you screw it in. So the part is done. Now you just need to slide it in here and put the rubber bands on. You can see there are dedicated channels for rubber bands, and when you want to put your phone in, you can do this, slide your phone in, and then just do like so, and it just snaps in. And the last part is attaching a strap. I'm using a strap from some old analog goggles, but you can probably buy straps like this online as well. And the strap just goes through this part. Like so, and then it goes through the slots here. And before you fly, you'll need to attach the antennas here, but I often take them off for transport, so that they are not damaged when I put the goggles in my bag, but ready goggles look like this. You can use other antennas, just make sure they are tuned for the right frequency you're using. I'm using 5.8 GHz, for FPV with this OpenIPC quad. So I'm using 5.8 GHz Pagoda antennas, which can also be assembled from PCBs. So these goggles work with the Pixel Pilot app, which you can get from GitHub. It has some options like VR mode, you can select the channel number, you can adjust the different elements on the OSD, as I have the recording button, video stats here. And also here you can select the gs.key file, which is like a file that allows the phone to decipher the video from the drone, and the drone has a corresponding drone.key file. So I'll plug my drone in. And we are getting video. So as you can see, I have VR mode enabled, which means that the image is shown in two identical tiles. I can change the position of the tiles using the two sliders, which is just to make sure that the tiles are in the right positions for the lens and for your eyes to be centered. So typically, when I am ready to fly, I will disable Wi-Fi, disable volume, turn on airplane mode, and disable automatic brightness, because you don't want it to lower brightness once you put it in the goggles. And here I just press record. I slide it in like so, and connect. And we are getting video. So as I mentioned, the Wi-Fi module board inside was manufactured by JLC PCB. And they also manufactured this board for me, which was actually my first time ordering a board with the assembly service. And as you can see, the parts are very nicely assembled. This part was designed to hold two such Wi-Fi modules and have a USB hub. So you would connect a USB cable here, and it would essentially split one USB connection into two Wi-Fi modules and also some additional interfaces. But unfortunately, this board didn't work because of some issues with the chip it's using, or maybe some capacitance values. I don't know yet what the main issue was, but yeah, unfortunately it didn't work. And JLC PCB also sent me these boards for making triple feed patch antennas, so I might try making some antennas like this in the future and stick them onto these goggles and see if I can get some better range, because these antennas are directional as opposed to Pagoda ones, which try to be as omnidirectional as possible. In case you don't know, JLC PCB is a custom PCB manufacturing service. All you have to do is upload the Gerber file of your design, adjust some parameters, and your PCB is ready to order. So I hope you found the video useful. Thank you for watching, and in the future I might make a video showing you the details of how I made this OpenIPC drone. So stay tuned for future videos. Bye!